Take it away.
Hello, everyone, and welcome to today's webinar. My name is Mohsen Khalaf. I have a PhD degree, and I'm a P.Eng in the province of Ontario, and I'm also a senior member in the IEEE. So we have a rich agenda today. First of all, I'll give introduction. I'll introduce myself, our company, and our services. Next, we have two mini lectures by two of our amazing lecturers, Ahmed Khairi and Mustafa El-Amshari. And the last item in our agenda today is our services and discounts. So a little bit about myself. My name again is Mohsen Khalaf. I am a co-founder of P.Eng Academy with my friends Mohammed Hamouda and Abdurrahman Ayad. Both are PhD holders from Canadian universities. I graduated from Asyut University in Egypt in 2012. I was the top of my class. I worked at the same department at the same university as a teaching and research assistant for 4 years. During that time, I got my Master's of Science in Electrical Engineering. Next, I started my PhD journey at the University of Waterloo in 2016, and I also worked as a teaching and research assistant at the same university. I got my PhD degree in electrical and computer engineering from the University of Waterloo in 2020, and I next worked as a postdoctoral fellow at the University of Toronto for 2 years. My PhD thesis and my postdoctoral fellowship work mainly focused on the cyber-physical security of power systems. I also worked as a part-time lecturer and lab instructor at the University of Waterloo and Conestoga College between 2021 and 2023. I got my P.Eng license in 2023, and now I'm working as a power system engineer at the Independent Electricity System Operator of Ontario. So let me now introduce P.Eng Academy. Our mission is simple. So we aim to support engineering graduates in Ontario and across Canada in achieving their professional engineer designation. The process of becoming a P.Eng can feel overwhelming with its technical exams, competency assessments, and application requirements. That's where we come in. At P.Eng Academy, we break down these complex steps into manageable milestones, providing the tools, resources, and guidance you need to succeed. So we're proud to offer tailored courses in core engineering disciplines, practical workshops, and one-on-one mentorship to ensure that every candidate is fully prepared. Whether you are just starting the licensure process or taking a specific challenge, P.Eng Academy is here to help you reach your goals and elevate your career. Whether you are preparing for technical exams, drafting your experience record, or needing clarity on the licensing process, P.Eng Academy is here to ensure you are equipped to succeed. You can always reach out to us using our website, Facebook, and LinkedIn through these links here. So at P.Eng Academy, we have designed our services to address these exact challenges, the challenges of being overwhelmed, of the P.Eng being overwhelming for different engineers. So I'm going to highlight a few of our services here. We provide comprehensive technical exam preparation courses in 3 engineering disciplines. Our courses are designed and taught by experienced instructors who understand the process firsthand and have proven teaching experience. Our expert mentors are available to guide you through every step of your preparation, offering personalized advice and assistance. We also host regular workshops and webinars focused on critical topics to deepen your understanding and reinforce key concepts. This is the second webinar in 2025, and we had one webinar in 2024. From navigating the application process to guiding you through the competency-based assessment experience report, we ensure you are supported every step of the way. So choosing P.Eng Academy means having the the right tools, guidance, and support to achieve your goal of licensure. This is a quick highlight of the courses that we offer in different disciplines or different engineering disciplines. For electrical engineering, we offer 3 courses in category A and 1 course in category B. For mechanical engineering, we offer 3 courses in category A and 1 course in category B. For mechatronics, we also offer 4 courses in category A and 1 course in category B. And for the complementary studies, we offer the engineering economics or CS1. So you can see here from the list that we offer more than 2 courses in group A, which means that we have more options and like flexibility. We provide more flexibility for the student to choose from. So for the mechanical engineering courses, which is the topic of today's webinar, we offer applied thermodynamics and heat transfer or mechanical A1. We also offer kinematics and dynamics of machines, mechanical A2, system analysis and control, mechanical A3, and environmental control in buildings, mechanical B3. Today, we will have a mini lecture and an introduction about mechanical A1 and mechanical B2. But before we go into this, I have this slide here to answer some of the frequently asked questions about our courses. So about the content of our courses, the content of our courses is exams oriented. So it covers all the concepts and it covers all the previous exam ideas. So during the course, we cover all the ideas that came in the previous exam so that you can be prepared and you can be ready for your exam. The duration of our courses, the average duration of any course is around 25 hours. It's approximately 12 hours with 2 hours each. Sometimes it's like 1 or 2 hours more or less depending on the course and depending on the level of the students. We also have a maximum of 6 students for course or for group for better engagement. As per the study material, we provide the recorded lectures. We record all our lectures and we provide limited access to our recorded lectures until the day of the exam. And also there is the PEO references that are always available for more information. So now I will introduce our instructors for today. Ahmed Abdel Hamid for Mechanical A1 and Mustafa El for Mechanical B2. I will start with Ahmed. Ahmed has a PhD degree from the University of Waterloo, specializing in turbulent combustion modeling. He has extensive teaching experience in different courses at the University of Waterloo and at Cairo University, focusing on thermodynamics, fluid mechanics, and heat transfer. Mustafa El-Amshari is a result-oriented mechanical engineer with extensive experience managing, planning, and executing complex projects in the nuclear, energy, and oil and gas sectors. Mustafa has more than 10 years of demonstrated engineering experience in multinational companies in Canada, the USA, and the United Arab Emirates. His expertise spans mechanical engineering, project management, team leadership, and stakeholder relationship management. He possesses strong technical and commercial acumen, consistently delivering profitable projects while fostering collaborative, high-performing teams. Mustafa holds PMP and CIPS certifications. Now, I'll turn it over to Ahmed Abdelhamid to start the mini lecture of the Applied Thermodynamics and Heat Transfer for Mechanical A1.
Okay, hello everyone. Let me share my screen. Okay, so in this mini lecture, I will talk about mechanical A1 course. applied thermodynamics and heat transfer. First of all, about me, my name is Ahmed Abdelhamid. I am a recent graduate from PhD from University of Waterloo. My research was focusing on turbine combustion modeling using computational fluid dynamics with advanced combustion and radiation models. I have been a teaching assistant in thermofluid related courses such as thermodynamics, fluid mechanics, gas dynamics, heat transfer at the University of Waterloo and also at Cairo University, from which I got my master's and bachelor degrees. So as you can see, the course consists of 12 lectures, and it's divided into two main sections. First of which is thermodynamics part. For thermodynamics, we have 6 lectures, starting with introduction and the fundamental of thermodynamics, then the psychrometry and analysis of ideal gas cycles. Then we'll talk about the Rankine cycle, Otto and diesel cycles, Brayton cycle, vapor compression refrigeration cycle. Then for the heat transfer part, we also have 6 lectures. First of which is introduction to heat transfer and steady-state conduction. Then we'll discuss transient conduction, following natural and forced convection, radiation heat transfer, heat exchangers, types and analysis, and finally thermal analysis and its applications. So let's start by giving part of the first lecture as a demonstration, a review of the fundamental laws of thermodynamics. The systems that are encountered in thermodynamics analysis can be divided into two main categories. First, things like piston cylinder configuration. This is what we call a closed system. In a closed system, we don't have any mass exchange, but we can have, of course, energy exchange across the boundaries. And in these systems, the mass is said to be conserved. On the other hand, open systems like a nozzle, as we can see here, can feature open boundaries from which flow can enter or exit the system. And in these kinds of systems, we use a control volume to estimate the changes in the system under consideration. Any system can be characterized by a certain set of properties thermodynamically, things like pressure, temperature, volume, and mass. And these properties can be classified into two categories. First is the intensive properties, which are independent on the mass or the size of the system. Things like pressure and temperature, this will be the same whatever the size of the system under consideration is. However, other properties such as the mass, total energy of the system, the volume, these are called extensive properties because they are dependent on the mass and the size of the system under consideration. Each system, also at a given instant, is said to have a certain state. At this state, the conditions of the system are defined, which means that all the properties of the system can be measured at this instant. And if the system is at equilibrium, this means that it doesn't have any unbalanced potentials. So if it is at a thermal equilibrium, for example, this means that there is an equilibrium in temperature between the system and whatever in contact with it in this equilibrium, for example, as in the surroundings. Similarly for mechanical equilibrium, physical equilibrium, chemical equilibrium. And to fully define the state of the system, we need at least two independent properties. For example, pressure or temperature to fully define the state, and consequently can from this state deduce the rest of the properties. There are two main forms of energy that are encountered usually in our thermodynamic analysis of a given system. These are namely the heat and work. Heat is a form of energy that can be transferred between two systems through different mechanisms. The mechanisms are conduction, convection, and radiation. Conduction occurs within materials of the same phase, for example, within the solids or within the fluids, but between different phases, like between solid and fluid, convection takes place. In contrast, radiation doesn't require a medium to transfer heat between bodies. For example, heat coming to Earth from the sun is transferred by radiation without a medium included in between. The other form of energy that is usually encountered in thermodynamic analysis is the work. Work is usually associated with a force acting over a certain distance. It can take different forms, whether it is mechanical, electrical, or magnetic. The first law of thermodynamics is also known as the energy conservation principle. It states that energy can neither be created or destroyed during a given process, but only changes from one form to another. So, for example, in this system here, this closed system, if heat is supplied at 15 kilojoule and rejected at 3 kilojoule, we expect so an increase at the internal energy by the difference between these 12 kilojoules. Similarly, in this case, if the system is insulated, but only work is supplied through this electric coil at 5 kilojoules, this means that the total energy of the system will increase by these 5 kilojoules. There are different forms of energy transfer within the system. There is heat transfer, work transfer, and energy transfer by mass flowing into the system, carrying energy. The difference between the net heat, work, and energy transferred through mass entering or exiting the system will constitute the change of the total energy within the system. The total energy is, in most cases, would be the change in the internal energy. If we neglect changes in kinetic and potential energy, which is usually the case in systems under consideration. So now let's look at a practice problem from previous exams. The problem statements say we have air contained within a piston cylinder arrangement as shown here. The piston is attached to a spring. The air is initially at 1 atmospheric pressure and 20 degrees Celsius. Within here, the spring has a constant which is given and is connected to the piston undeformed. So at the initial state, this spring is undeformed, not exerting any force over the air within the piston. We are required to know how much heat is added to the air So here Q, in order to increase the pressure to 3 atmospheric pressures from the initial value of 1, and given that the apparatus is surrounded by air of 1 atmosphere. So if we look into this, we have an initial state at which have pressure and temperature, and we want to get the values at the final state and consequently estimate how much heat is needed to reach this final state. What we know about the final state is that it has 3 atmospheres. So if now the air is at 3 atmospheres and the surrounding air is at 1 atmosphere, this means that the piston here with a spring is exerting these additional 2 atmospheric pressures over the air. So we want to estimate the force that is produced by the spring in this case. So now, knowing that the difference in the pressure of 2 ATMs is what should be applied by the spring over the piston, and the cross-sectional area of this cylinder is given, we can multiply the pressure by the area to get the force exerted by the spring. Now, if we have the force and we have the spring constant, we can estimate how much this spring has moved, and consequently the piston. We calculate X as F divided by K, which would be like about 8 millimeters. So we know now that the piston has moved this delta X, and if the piston moved this amount of distance, this means that we can now estimate the new volume. We can add the added length multiplied by the area to whatever volume we have initially to get volume at the second state. If we have the volume and we also have the pressure at the second state, we have 2 properties. We can estimate the rest of properties from this. So now we can calculate delta V as the cross-sectional area multiplied by the change in piston covered length, which would be about 3.2 to the 10 power negative 6 meter cubic. Adding these changes in volume to the initial volume V1, we can estimate V2. And now if we have V2 and we have pressure 2, we can use the equation state, which says P equal has different forms. We can say P equal rho RT or PV equal MRT, or if we are comparing 2 states to each other, we can just say P1 V1 equal P2 V2 over here. And from this form, we have P1 V1 T1, we have P2 V2, we do cross multiplication to get temperature at 2. You only need to make sure that you are using temperatures at SI units in kelvins, so that you get the correct value. This gives us a final temperature T2 of 1020 kelvins. Now we have the final temperature. We can estimate how the internal energy of the inside air here has changed by calculating delta U equal mCv delta T. We have delta temperature calculated. The mass can be known from the equation of state as well. And so this gives us about 12.4 joules added as an internal energy. The final part to calculate is how much also work is exerted by system here moving the piston and compressing the spring. The formula for calculating the work spring is half kx squared. This can be easily used from the definition of work, which is the integration of force over dx, and knowing that the force is equal to kx, we can say that the integration of kx dx is equal to half kx squared. K is a given, x is calculated from previous steps. We can calculate finally the work done compressing the spring. Adding these two from the first law of thermodynamics, we can find finally how much heat should be added to get the system from state 1 to state 2. And this is estimated to be about 12.7 joules. This concludes this mini lecture. So thank you for listening, and I pass it now to the next instructor.
Thank you, Ahmed. So before we go to the next mini lecture, does anybody have any question about the lecture topic? Or maybe
Yes.
about the course, Mechanical A1? I know some people are not comfortable in asking questions. So if you want, you also can type it in the chat.
Yes, sure.
Okay, so thank you, Ahmed. Thank you everyone for listening. We'll move on now to the next mini lecture with our instructor, Mustafa.
Okay, good evening, everyone. It's a pleasure to be here on this mini lecture with all of you, and thanks, Mohsen, for the introduction. To have a quick brief on what will be on the what will be the course that we're going to be going through in this mechanical B2. So the previous lecture, Ahmed, he went through the thermodynamics. What I would like to describe this course is more, it's like this is, it takes the thermodynamics laws into real life applications. So we will be going through multiple topics that I will go through in this mini lecture. But before doing this, a quick introduction to myself. So I graduated from the Mechanical Engineering Department from Alexandria University in Egypt back in 2011. Ever since, I've been I would say, in the workforce. So I started out my career in the oil and gas industry as a rotating equipment engineer. However, I was not just exclusively working on such equipment. I was also supporting static equipment as well as HVAC applications within the oil and gas sector. Then within the oil and gas, I transitioned into the proposals engineering. So my scope wasn't just limited to the mechanical aspect of things. It was into all engineering aspects. We're talking about process engineering, electrical, INC, all design aspects that would come into play in order to construct an oil and gas refinery or a processing facility, depending on our scope of work. However, during this period, this is where I started to be more involved into understanding various standards from different parts of the world and how they apply into each country and each industry accordingly. Also, not just that, but tying all of this technical knowledge into commercial aspect as well. Because in the end of the day, I think we all work for companies that are after profit. So this means that we are as engineers or as decision makers in the industry, we are trying to tie those two things together. Sometimes the perfect design is not applicable in real life, but it doesn't mean that when you take your second option or third option of design, you're compromising your production or your project. So I can talk about that for as many time for as much time as I could get, but um, then I transitioned into the power generation, nuclear, specifically nuclear power generation here in Canada. Over the last 7 years, I've been in the industry where I covered all components within a nuclear power plant, starting from the reactor down to the turbines and generators and every system in between. This those years of experience involved the inspection and maintenance work. It involved design engineering projects. So as you go, when you if you are looking forward into getting into the design engineering industry in Canada, you had, and depending of for sure, depending on the industry and the process, there are multiple steps of design. You start from conceptual design, transitioning through multiple gates of reviews and details until you reach the detailed phase. And your role as an engineer doesn't just stop as submitting your design and putting the stamp on your drawing or your procedure. It also goes to the application of that system, the installation, the commissioning, applying field changes, and as a professional engineer, as you will be involved, I would say, in all these aspects, depending on your company that you will be working for. And also, I managed the full EPC spectrum of the project. So from project management perspective, we call it cradle to grave. E stands for engineering, P stands for procurement, and C stands for construction. So I am and was responsible for many projects where you have to whether redesign or make upgrades to systems. To those who don't know, most of the nuclear power plants in not just in Canada, but in the entire world are 30 or 40 years old or even more. And in order to maintain your license to operate, there are a lot of upgrades that you have to go through, a lot of new requirements that you have to follow. A lot of design aspects are obsolete. So you will, if you are lucky enough, you will go through all these upgrades, which is something that is very exciting. And again, maybe during our lecture, I can elaborate more on such things. And right now, over the course of the last 2 years, I transitioned to be the services manager for General Electric or GE Vernova, responsible for all the nuclear fleet in Canada across multiple nuclear power plants. So I'm responsible for all the maintenance and upgrades to the steam turbines, generators, and auxiliary systems. I hope I didn't bore you with all the those details, but moving on to our table of content. So over the
Hi,
course,
Hamshari.
yes,
Papa, you're not sharing the screen.
I'm not. Oh, sorry,
No,
I thought I was. My bad.
that's okay.
Okay,
Yes, now we can see it. Perfect.
it sort of reminded me. since I was talking. Okay, no problem. So yeah, talking about the course for this B2 course, we will go through 12 weeks approximately. On the first week, starting next Sunday, we will go through the some fundamentals of heat transfer. The core of the course will be geared around refrigeration cycles, cycle modifications, going through the psychometric charts and processes. And we will be talking about the load calculations, system designs for HVAC systems, duct design, and cooling towers, as well as compressors. So for today's mini lecture, I wanted to give the listeners or the attendees here a small taste of what to expect in the exam. So this is one of those problems coming from the December 2019 test. I will not go through it step by step, as I will be more thorough on Sunday's lecture. But it just gives you a taste on what to expect. So, like when you have multiple layers of walls and barriers, and you want to calculate the heat transfer from one side to the other. So in this particular problem, we are looking into convection as well as conduction. And if you would like to, the way I like to treat it and the way that we will go through it in this course is like when you compare it to electrical circuits, where the heat transfer is considered as the current that goes through your line, and that each wall is a resistance. If you remember, or if you've been in touch with, or if you studied electrical circuits back in university days, you would remember that there are parallel and series resistances. So to put it into a schematic, this problem translates to what you see here at the bottom, where you have temperature, ambient temperature on one side of the wall, and the ambient temperature on the other side of the wall. It goes through multiple phases of resistances that dissipates or absorb your heat. So yeah, it starts from the as I mentioned, from the inside, which is the convection side, and then moving on with the first surface, then the second surface, and then you have an air gap in the middle, and then the outer surface, and then to the outside, or to the atmosphere. In order to move on to the next step of this problem, you will have mainly you will be needing to calculate the resistance of each and every medium. And as I mentioned earlier, you have convection, like you have the convection resistance, which is calculated by this formula that you see. And then the conduction resistance, which is the following formulas. And once you deduct all these values, you will be able to, in this case, the request was to calculate the total resistance of the wall. And in other applications, we will see more complex examples where you go through how heat is getting transferred through cylinders, spheres, when you have multiple, when you have like a wall with windows. And then once we go through the course, we will talk about concepts of heating and cooling depending on the surface. Is it something, so when you're designing a system, for example, for a warehouse, it's different than when you're designing a system for a cinema theater, for example, even though it's the same area that you want to cool or heat. but depending on the application, the heat emitted from the occupants or from the equipment or tools or parts that are inside this building. Yeah, we will go through a lot of exciting stuff, and yeah, I'll be looking forward to have more discussions through the next 3 months. With that, any questions? Okay, hearing none, I will turn it back over to Mohsen or Abdurrahman. Thank you.
Okay, thank you, Mustafa. Any questions from anyone? As we mentioned, feel free to write a question in the chat if you don't want to interrupt us.
Assalamu alaikum.
Alaikum salam.
Okay, may I ask like few questions about the preparation? Now, first of all, I think all of us are Arabs, I guess. So am I right?
I'm not sure. So if you wanted the chat is Arab, do you mind if we like do you want to
يعني
ask?
لو تكلم الواحد بالعربي حدا عنده اعتراض؟
Go ahead. Like we will translate the question if needed.
No, it's okay. I can speak in English, no problem. But the thing is, I thought you might express yourself much better in Arabic, especially if we are all Arabs. So I don't think it's a big problem to speak in English. The thing is, now regarding to the courses or to the, let's say, to the topics that you have mentioned, both of the engineers, and I do cherish and welcome them and appreciate their lectures. What I'm trying to say, if you are going to give us those like 2 hours a lecture for like 12 weeks or 12 lectures, so we talk about 25, 24 hours. Are you, both of you, I mean, like, so sure that whenever you are familiar with the material being discussed in these 25 hours, do you think we will be able to manage and pass the test?
Yeah, so in general, actually, we tailor our courses to so that you can pass the exam easily. We focus on explaining the important concepts and giving ideas of all the previous exams. So this is our strategy for all the courses in mechanical, electrical, and mechatronics disciplines. So by the end of any course, you should be able to pass the exam, and for sure. This also requires some work from your side. So after the lecture, it will require some time from you to go through the materials of the lectures, to go through the previous exams and all this stuff. So anyone from the lectures, would they want to add anything?
So again, let me emphasize on one thing. For example, if we discussed, for example, for a lecture, for example, for 2 hours, suppose we solved like, let's say, 3, 4 examples, 3 questions, 4 questions. For example, let's talk about, for example, the heat transfer. We like, let's say, cover the conduction heat transfer, the convection heat transfer, radiation heat transfer in this lecture. And we, let's say, solve like 2, 3, 4 examples. So for sure, the 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 test questions will be like in the same, let's say, in the same manner, in the same way. Nothing is gonna be, outside those 2 or 3 examples. So if I just focus on those 2 examples, for sure that I'm gonna pass. No tricks in the exam, or actually maybe sometimes it's not just like tricks, it's just like different topics.
Yeah, so I mean, like we do our best to cover all the concepts, all the important concepts, and all the ideas in the previous exams. and like as we say in Arabic يعني احنا بنعمل اللي علينا والباقي على الله. So like we do everything possible that we can do in the course to prepare you for the exam, and like as long as we do like the preparation for the courses, like nothing is guaranteed honestly, but like everything comes with dedication. Like we prepare everything to our best. You need to do your part also. You need to study the material to review the previous exams, and then when it comes to the exam itself, like we hope uh, we hope for the best. So usually some exams or some ideas in the exams are repeated from previous exams, but there are always some tricks in the exams as well.
Okay, and now regarding, is there like a material so we can study by ourselves, you know?
Yes,
And
yes. So I
can you share it with us?
exactly. So I talked about the study material. So the study material for our courses will be the recorded lectures. You will be given access to all the recorded lectures until the day of the exam.
So you talk about also the lectures that we are going to attend, but I meant something else about, is there like a book or something like notes or
So
studying material
this
outside so I can study it without listening to lectures?
so actually the main part of our course is like attending the lecture and listening to the lecture. And for the books, there's the references that have been provided by PO.
So can we have those courses provided
Sure.
by the PO?
Like we can give you the titles of the books, and then you can find them online for sure.
Okay, okay. If it's possible, you know, to just send me the link or something like that, that would
Sure.
be much easier, I think,
Yes, I
and
definitely can do this.
it will save more time.
Sure,
Thank
sure.
you for thank you for your
You're welcome.
everything.
You're welcome. Thank you. Any other question? Yeah, there is a question in the chat here for Mustafa. I have graduated more than 10 years ago, and so I forgot many of the fundamentals. Will you give a background overview to refresh our memory?
Yes. So we will go. Yeah, I will not make. I think, and I think it depends on the group, but speaking of such item for each course or for each week, we will try. We will go first with some fundamentals, but we will not make a big stop at it, as we will evolve, as we will evolve through the course. Um, and for sure, if there are any questions or if there are any additional effort that is needed, we can look into these options. I believe there are a lot of resources that are available to everyone to look into these basics. So yeah, I will try to, if we have the time to go through these basics and carry on with our course, then fine. If not, then we can look into additional options as we go. But I'm sure that we can support it on as needed basis.
Okay, thank you, Mustafa. I
Yeah,
hope this-
and I would like just to add one thing to Mustafa's answer in general. Um, as you know, P.Eng is providing courses in different disciplines, but for all courses, we have small groups of students between 2 and 5 maximum students per course, which means that the instructor will be able to tailor any additional materials that you need, any specific concepts or parts of the exams that you need more attention to. The small courses, the small number of students allows us to be more flexible in terms of going through specific areas of background or the exams, and making sure that we can solve the exams. So also relevant to the other question on the exams, all our instructors have extensive experience with previous exams, and they know the patterns in exams, and we see that generally the exams do not attempt to have difficult questions per se or tricky questions or a lot of changes from year to year, because at the end of the day they know that they're testing engineers who have already graduated from universities. They just want to make sure that they have the essential background material. So this is going to be the main focus of the exams, and all the instructors know the previous exams, which will be shared with the students in the class. So this is also part of the materials that's going to be shared, because one of the questions is about the materials. So the materials, yes, will be the recordings of the sessions, will be the exams or the solutions, and any other materials in terms of guidance to references books, to notes that can help the students study for the exams.
And one more thing to add, Abdurrahman, for like coming from the industry side, whether you will be taking the PEO exam or attending the interview or being in a real life situation, you will not like you will not be using like going back to the days where we were at the university, being asked for like to memorize the laws or type in and solve problems. All these things like in real life are being like resolved like using softwares or stress analysis, or depending on which part of the engineering that you will be working on. The main purpose of those exams is to test your critical thinking, test your knowledge, or how we can translate. For example, when we will go through my course later on, some of those, for example, questions or problems, they don't have an illustration or a drawing. You are presented with a situation, and you will be, and part of the problem at the beginning is you were trying to illustrate it, try to visualize it, and then resolve it. Once you have once you have those givens in front of you, it will be a straightforward answer, but it's just a testament to your critical thinking as an engineer. So that's one of my observations looking at those previous exam problems.
Thank you, Mustafa. Thank you, Abdulrahman. I think we answered the questions in the chat. So any other questions or any other follow-up? Okay, thank you, Abdulrahman. So I'll share back my screen here to talk about our last part of our in our agenda, our services and the prices. Do you see my screen?
Yes.
Okay, so we offer different services here. So the first service for sure is courses. Like we have special price if you book 4 courses. Like the price for one course is $500 per course, and as we said, the average is like 25 hours or 20 hours for some courses. And if you book 4 technical courses, this is gonna cost you 1,800. If you book for 4 courses and the CPA consultation, this will cost $2,000. And just to mention that the CPA depends on the personal experience, so we cannot do this on our own. So this is only like a consultation if you need help or if you wanna discuss your experience with us, and we help you on how to write it so that it sounds okay to PEO. And this is if you want to only book the CPA consultation plus feedback on the CPA, this costs $300. For a general consultation about your pathway on the P.Eng, for example, this is $50 per 30 minutes, and we're offering this for free as of now. So the launch offer that we have for now is 15% off the courses if you book the exam for the May exam setting, and you need to book by January 31st. It's like 2 days away. So for the webinar attendees only, we have 15% off all our services, not only the courses. So the 4 technical exams will come to $30. And if you book only 1 exam, it will be $425. And for sure, the CPA review is for free for webinar attendees only. So if you're going to book 4 courses and review the CPA, this will cost the same price as only for technical exams, which is $15.30. So yeah, this is only for 1 week special. The CPA consultation is free regardless of booking the exams. If you want us only, or if you have any questions about the CPA, this is free until February 5th. So that's all about it. It's your turn now to take your first step regarding towards your P.Eng licensure in Ontario. If you have any questions, you can ask us now, or you can always reach out to us through our website, social media, email, or chat or call through this number here. So
excuse me, one question. What do you mean by the CBA?
the CPA is this is the new system in Ontario that you file your experience through, so that they can evaluate your experience. Usually in the past, you used to submit something called experience record, but now there's a new model. It's competency-based assessment. There are 34 competencies that you need to satisfy. You need to like mention situations or mention like something from your experience to answer these questions, or to like to meet this specific competency. Does this answer?
And the abbreviation for the CBA, it's for what exactly?
So reviewing the CPA is for $300, but like for now, because you are attending the webinar, this is going to be for free for you if you do this within a week.
No, I just wanted to know that the abbreviation for the CBA, it stands for what?
It's competency-based assessment.
Oh, yeah. Okay, thank you.
You're welcome. So another question. I saw something in the chat. I can't see the chat now. Let me just check.
No, I was just putting the links for the CBA from the PU website and saying the abbreviation of the competency-based assessment. So yeah.
Okay, so if no questions, thank you again, everyone, for joining us today. It was our pleasure having all of you and discussing with you and answering your questions. If you need any other questions, any help, just feel free to reach out to us. Thank you very much.